All right, let's just jump right in. Think about it for a second. The food you eat, the clothes you're wearing, even the very cells that make you, you. At the heart of it all is one single element: carbon. It is, without a doubt, the ultimate building block of our world.
But that brings up a huge question, doesn't it? How can just one element be the backbone for pretty much everything? I mean, from living creatures to plastics and fuels. This is the great carbon mystery we're going to unravel today.
And the mystery gets even deeper when you look at the numbers. In the entire crust of the Earth, carbon only makes up a teeny tiny fraction, just 0.02%. That's it. It's actually incredibly rare.
And it's the same story up in the atmosphere. Only about 0.03% of the air around us is carbon dioxide. So, with so little of it to go around, how in the world did carbon become so important? Well, the secret isn't about how much there is, but how it connects with everything else.
To really get to the bottom of this, we have to zoom way, way down to the atomic level. We've got to talk about something called the covalent bond. This, right here, is where all the magic happens. You see, most other elements form bonds by either giving away their electrons or straight up stealing them from other atoms. It's kind of like a transaction. But carbon plays a totally different game. It doesn't give or take, it shares. And that one little difference changes absolutely everything.
And the sharing creates what we call a covalent bond. It's basically a partnership where two atoms share a pair of electrons, which makes both of them stable and happy. It's a total win-win, and it creates a bond that is incredibly strong and stable.
Let's look at the simplest possible example. You take two hydrogen atoms. Each one has one electron. They can share those electrons and boom, you get a stable hydrogen molecule. That little pair of dots between them, that's a single, super strong covalent bond.
And you can even level this up. An oxygen atom, for example, needs 2 electrons to feel complete. So 2 oxygen atoms can get together and share 2 pairs of electrons. This forms an even stronger connection called a double bond. You see the pattern here? It's all about sharing.
So, because carbon is the master of these covalent bonds, it has 2 unique properties that honestly are basically superpowers. These 2 abilities are what allow it to create millions and millions of different compounds.
Okay, superpower number 1 is called tetravalency. I know, it's a mouthful, but all it means is that carbon can form 4 bonds at the same time. Superpower number 2 is catenation, and this is a big one. It's the amazing ability to form long, stable chains by bonding with other carbon atoms. No other element can do this anywhere near as well. And check this out. This is a perfect picture of tetravalency. This is methane, the simplest carbon compound you can get. See that carbon atom right in the middle? It's sharing electrons with 4 different hydrogen atoms, forming 4 separate stable bonds. It's like the perfect 4-sided connector. Now for that other superpower, catenation. This is carbon's party trick, linking up with itself over and over and over again. It can form chains that are straight, branched, or even curled up into rings. This is what lets it build the massive, complex molecules that life depends on. And you can see exactly how it works right here. You start with 1 carbon, that's methane. Link another one on, you get ethane. Add a third, and you've got propane. A fourth gives you butane. These chains can just keep on growing, all because that carbon-to-carbon bond is just so unbelievably strong. So let's put it all together. What happens when you combine these 2 superpowers, the ability to form 4 bonds and the ability to link together in long chains? You get an almost infinite variety of molecules, literally a world of compounds. This is just mind-blowing. On the left, you've got diamond. Every carbon atom is locked into a rigid 3D grid with 4 others. On the right is graphite, where each carbon is bonded to 3 others in flat sheets. It's the exact same element, but one is the hardest substance on Earth, and the other is so soft we put it in pencils. It all just comes down to the bonds.
But wait, there's more. Carbon's versatility doesn't stop there. It's a super friendly element, so it happily bonds with other things like oxygen or chlorine. And when these other elements hook onto a carbon chain, they create what we call functional groups, which give the molecule totally new properties, creating things like alcohols, acids, and so much more.
Okay, this is all fantastic science, but let's bring it back to the real world. What's the payoff for us? Well, let's look at one amazing example that uses everything we just talked about, the simple act of washing your hands with soap. So first, let's set the stage.
You know how most dirt is kind of oily or greasy? And we all know the old saying, oil and water don't mix? It's true. So if you just rinse your hands with water, that oily dirt isn't going anywhere. It's stuck.
But then, enter our hero, the soap molecule. It is a masterpiece of carbon chemistry. It's got this long carbon chain tail that is hydrophobic. That means it fears water, but it loves oil. And then it has an ionic head that is hydrophilic. It loves water. It has a total split personality. So when you lather up, these soap molecules pull off an incredible trick. They automatically arrange themselves into these little spheres called micelles. All the oil-loving carbon tails point inwards, creating a safe little pocket for oil, while all the water-loving heads face outwards to hang out with the water. And here's the result. That oily piece of dirt gets trapped right in the middle of that micelle. The hydrophobic tails grab onto the oil like a magnet, and the hydrophilic heads on the outside let the whole bubble get carried away by the water. It's like a tiny capture crew for dirt. So let's just recap that cleaning action. Step 1, the soap molecules swarm the oily dirt. Step 2, their carbon tails dig in and grab the oil. Step 3, their water-loving heads face out. And step 4, the whole package, the micelle with the dirt trapped inside, gets lifted off the surface and rinsed away. Just brilliant. So, it's pretty amazing, isn't it? From being this super rare element in the Earth's crust, carbon's two simple superpowers, forming 4 bonds and linking up with itself, give rise to the incredible complexity we see all around us, from our own bodies to the soap we wash them with. And that brings us to a final thought for you. We've really only scratched the surface here. Now that you're in on the secret, now that you know how carbon works, what other everyday things are you going to see in a whole new light? From the plastic bottle on your desk to the medicines in your cabinet, it all comes back to the simple, elegant power of carbon.